Assalamualaikum everyone. In this video, we're going to learn on chapter 6, phase equilibrium. Throughout this chapter, we are going to learn on definition of phase, component, and phase rule. There will be two systems that we are going to have a look. First one component system, which is contain of phase diagram of water and carbon dioxide, and the second system will be two component system, which we will learn on Roots law, two completely miscible liquids, vapor pressure, composition diagram, fractional distillation and azeotropic system, and two completely miscible solids. Phase is a homogeneous part of a uniform system, chemically and physically separated with other parts of the system by a well-defined boundary. In a system, there can be solid, liquid, or gas phase. For example, water can exist as ice, which is solid phase, liquid, which is liquid phase, and vapor water, which is in gas phase. These phases can be coexist in any combination of two phases, even three phases at one time. Gas or gaseous mixture can only exist in single phase. For liquid, it can exist in one, two, or three phases. For example, homogeneous miscible liquid exists in single phase because all the components in the homogeneous liquids miscible with one another. It can also be two phases whereby we have immiscible liquid, for example, oil and water. For solid, a crystal is a single phase, and solid can form an alloy, which alloy exists as a two phases that contain two metals. It is easy for you to understand that miscible liquid is one phase, mixture of immiscible liquid is two phase, and substance that coexist in three different states, for example solid, liquid, and gas, will form a three-phase system. Now we move to miscibility. So miscibility is the ability of liquids mixtures components to mix with each other. So it is qualitative rather than quantitative observation. So there are three types of miscibility. First one is the miscible. Second one is partially miscible, and last one is immiscible or not miscible. To state exactly how miscible two liquids were, scientists always use the concept of solubility. So, in solubility, we understand we have a substance, or also known as a solute, that will dissolve in a solvent, forming a solution. Okay, so this solution can be is either miscible, partially miscible, or immiscible. Okay, so a simple example, let's say we want to prepare a glucose solution. So we have a solute, okay, solid of glucose, and then dissolve in a solvent, which is our solvent here is water, and we will get the glucose solution. So the glucose solution is forming a single phase, as all the glucose will dissolve completely in water, forming a homogeneous mixture. We also can relate with the polarity, whereby the rules of thumb, light dissolve light. What does it mean by light dissolve light? Okay, so polar will dissolve in polar, okay, and non-polar will dissolve in non-polar. So for the miscible, the liquid form a homogeneous mixture and it mixes completely to form a single phase. For example, ethanol and water. So when ethanol mix with water, it will form ethanol solution, which is a single phase. For the immiscible, the liquids cannot mix together at all. So the volume is the total volume of liquids added originally. For example, we have oil and water. So oil is non-polar, whereby water is polar. Okay, so non-polar will not dissolve in polar. So for example, we have 50 ml of oil and 50 ml of H2O. So it remains 50 ml of oil on top of the water layer and 50 ml of water, and brings the total volume will be 100 ml. To understand on components, I take example of water. We know that water exists in three phases: solid, liquid, and gas. So these three phases can express as the same chemical formula, which is water H2O. So it is called as one component system. The table shows the number of phase and component for a certain system. For example, a system contain gas of oxygen, carbon dioxide, nitrogen, can be nitrogen dioxide and nitrogen monoxide, and many more components. Second example, water and ethanol system. So both water and ethanol are liquids and that involve two components in this mixture, water and ethanol. Next example, water and tetrachloromethane system. Both are liquids, but because they are immiscible with each other, so there are two phases involved and two components. Same goes to sulfur alpha and sulfur beta mixture. Both are solid, but because they have their own lattice properties, so the number of phase is 2 and the number of component only one, which is sulfur. In understanding the phase rule, we understand that there will be a relationship between variance or degree of freedom, the number of components, and the number of phases at equilibrium for a system of any composition. So what is degree of freedom? It is the number of variables that can be changed independently without changing the phase of a system. So degree of variable we can calculate with the formula F equals to component minus phase plus 2. The 2 here is indicate to two intensive parameter, which usually we consider temperature and pressure. Understood, this degree of freedom formula It only applies to the system in chemical equilibrium.